Hey Comets, welcome to a video series specifically on the Math Plus portion of the packet. I'm going to start on the week 7 since I'm probably not going to get through this section because I don't think we're going to get that far on the regular Math 6. So I thought, well, why not post some videos on this? I'm going to try to get as much into one video as I can. All right, here we go. All right, so I'm looking at this Math Plus for week 7 and 8. The first thing we see is working with data. Okay, now if you were in the honors class, you saw this. If you were not, if you're in a regular math core class, you didn't see this because this is what we were going to cover when we got back from spring break. So this is great if you're going through this because that's going to help you next year when you guys review this. Okay, so working with data. All right, when analyzing graphical data, you can also look for any interesting patterns such as clusters, gaps, peaks, outliers. Okay, clusters are where all the information is grouped together. Gaps is where there's space in between. Peaks is when there's one standing out from any other, and then outliers are where there's a little bit of information out to the side. Okay, and then symmetric, skewed right. You would think that this is skewed left, but remember, it's skewed because most of the data is right here, but there's a few outliers over here pulling the data set over, okay? That's why it's skewed right. So it's the opposite of what you might think. Same with skewed left. Most of the data is over here, but these are pulling it to the left a little bit, okay? So describe the shape of the distribution, then label any clusters, gaps, and outliers. Okay, so let's take a look at this graph. All right, I see most of the information lying over here. So what are these points doing to it? Are they pulling it to the left? Or are they pulling it to the right? Okay, I would say it is skewed right because most of it's right here. Okay, there's a few over here pulling it to the right just a little bit. Okay, now I would say that this is a big cluster right here. Okay, the highest point is this right here. So this would be our peak. And there's definitely an outlier and there is a gap here. Okay, and I guess you could say that this is a gap as well, all right? But that's because this is an outlier, all right? Now, dot plots. The way this works is each X represents a value, okay? So a number of countries that won that many gold medals. So according to this graph, there's 1, 2, 3, 4, 5 countries that got 0 gold medals. If I look over here, 1, 2, 3, there are 3 countries that got 4 gold medals, okay? Because each X represents a true statement that there is somebody that got that many gold medals. So use the dot plot above, number of pets owned by students, to answer each of the following questions. What do the 3 X's above the number 4 represent? Okay, so above the number 4, we see 3 X's. Okay, so that must mean that there are 3 students, because each one of these X represents a student, that has 4 pets. Okay, why are there no X's over the number 3? Okay, well, there was no one who had 3 pets owned. Okay, and how many students owned 1 pet? Okay, so look for 1 pet and then count the number of X's. 1, 2, 3, 4, 5. Okay, so 5 students owned only 1 pet. Okay, we would be way out here if you've been watching some of my other videos. You know, we've got a lot of pets. All right. Okay, create a dot plot for the values listed showing the number of siblings students have. Okay, so what I would do here, guys, is I would draw my number line. Okay, and I would just put an X over each point accordingly. Okay, I didn't do it enough, but this at least get us started. Okay, so there is a 3, so I'm going to put an X over the 3. Okay, there is a 4, so I'm going to put an X over the 4. Okay, there is another 3, so I'm going to put another X above the 3. Okay, there is a 2, so I'm going to put an X over the 2. All right, there is a 6, so I'm going to put an X over the 6. And I would just go through my list, putting an X for every time that number is listed. Okay, there is an X over the 0. Okay, there's an X over the 3. Okay, that gives us 3 so far. Okay, so in other words, I could go back through my list and count how many 3s are there. 1, 2, 3, 4, 5, 6. So I better have 6 X's above that number 3. Okay, and notice there is 1, 2 number 1s. So I better have 2 X's over that number 1, and so forth. Okay? So my graph is not big enough to account for all these numbers, but you get the main idea, hopefully. Okay? All right. Since we're moving kind of quick, I'm going to go on to the next page. Okay, we got a stem and leaf plot. All right? Stem and leaf plot is a graphical method used to represent ordered numerical data. Okay? So the first thing you probably want to do is if you have a set of numbers, is get them in order from least to greatest. Okay, I think that's going to help you out a lot. All right? The stem is all the digits in a number except the rightmost digit. Okay? So this is our stem. Okay, so these numbers each represent, for example, so over here it would be, this is a 40 and this is a 1. This is a 50 and this is a 6. So it would have 41 and 56. Okay, in this stem and leaf plot, I've got 0, 5. So that's 5, 0, 5 again, and 0, 5 again. 0, 6, 0, 6, 0, 6, and so on. This would be 41. This would be 56, this would be 42, and this would be another 42. Okay? So let's look at what that would look like on our, the one we are supposed to create. Okay? So again, I would write these in order of least to greatest. Okay? And then you would start putting them in order. So I would do, okay? For time's sake, I'm probably not going to do this whole thing as I think about this. So I'm going to, what's the smallest number here? I'm seeing a 50. I think that's where I'm going to start. I might do a 40 just in case there's a one that pops up. So I'm going to do 4, 5, 6, 7, 8, 9, and 10. I don't think there's anything over 100, is there? I think there is one 100. Okay? So again, I'm doing the rightmost numbers over here. Or I'm sorry, all but the rightmost numbers. And then so this is my stem. Then over here is my leaf. And I'm going to put, if there is something in the 50s, I'm going to put the ones digit over here. So let's see. I see a 52. Is there a 51? I don't think so. I think there's a 52 and another 52. So what I'll do is represent a 52 by writing this. Okay? And then there was a second 52. So I'm going to write another 2. What that means is it's not 522. It means there's one 52 and another 52. Okay, it's like listing. All right? And then was there any others in the 50s? Okay. I missed one. Look at that. There's a 50. Okay? So I got to go back and I need to move these 2's over. Whoops. So I've got a 50. I got a 52 and that second 52. Okay? So 50, 52, and then another 52. Then I would go with my 60s. Okay? One more time, double check for 50s. Not seeing. Okay, now 60s. I got a 65, another 65. I have a 68. Okay, there's a chance I'm missing it. Sorry if I am. So I have a 65, another 65, and a 68. So it would look like this. Here's 65, here's the next 65, and the 68. Okay, we'll do one more set. Now we want our 70s. We got 78, 77, 74, 78, and 71. So I would put my 1 here. I would put the 74. I'm putting a 4. And the 78, 77. So I think I got all the 70s. Okay? And that would just go on like that. Okay? Get the idea, I hope. Finally, we have a histogram. Okay? Now, histograms are a little bit different than bar graphs. You've probably seen bar graphs before. Okay, with a bar graph, it's kind of like a line plot, okay, a scatter plot, like we did here at the beginning. A histogram is different because it's how many fit between this number and this number. So the interval is between 10 and 20, 20 and 30, 30 and 40, 40 and 50, and 50 and 60, and so on. Okay? Frequency is how many are in that interval. Okay? So there are approximately 7 or maybe 8 buildings that have between 10 and 20 floors, apparently in this. Okay, and there are about 26 or 27 that are between 20 and 30 floors. Okay, so to make our own histogram, this is what we need to do. Okay, we need to write all of these intervals into our graph. Okay, because it starts at 0 and then goes to 2, 4, 6, 8, 10, 12. Okay, so we're going to have an interval from 0 to 10 floors. No, I'm sorry. 50 to 60. 60 to 70. 70 to 80. 80 to 90. And 90 to 100. Okay? So it should look like that. All right. Now, we're going to use our frequency to identify how far our bar should go up. Okay? I'm going to draw these lines across so it looks like what you have on your page. All right. So between 50 and 60, there are 4 buildings that have that many floors. Okay, so I'm going to draw up to here and I'm going to shade in that bar, indicating that there are 4 buildings that are between 50 and 60 floors. Okay, and then between 60 and 70 floors, I've got 9 buildings. So I'm going to go up to here, halfway between 8 and 10, and then that's going to be my bar graph there. Okay, and then between 70 and 80, there's 2. Between 80 and 90, there's also 2. Oh, I realize I didn't put enough space here. Okay, between 90 and 10, there's only 1. And then finally, between 100 and 110, there would be 2. Okay. Show you a little closer there. That's what that would look like. All right. So again, this is just telling you in that range how many buildings have that many floors. Okay. All right. I think for time's sake, I'm going to close out this video and then make another video for the next page. Okay. But we got 2 of the pages done in one video. Thanks for watching and stay tuned for the next. Thanks. Bye.